So equal tempered is the system today that you can see here. All the whole steps are exactly 200 cents, and then each half step is 100 cents. So what this system does is allow for us the capability. You can start your scale on any of the 12 pitches of chromatic pitches, C, C sharp, D, any pitch. You end up with exactly the same relationships of intervals of scale, depending on where you start. This is the only system of tuning which really does this, where you have all 12 pitches are equal distance. So it doesn't really matter which pitch you start on. You're going to end up with the same scale relationship. And so which allows the composer then to think about changing keys within a composition. This is the first time we've been able to effectively have the freedom to go to whatever key we want. So when we look at the history of Western music, for example, and how composers have modulated to various keys, really starting after the 16th century, where you start to find composers trying to move to other key centers, the more the tuning systems have adopted this equal tempered notion, or are getting moving toward that through mean tone and other ways, the more options composers had to modulate to other keys. So, for example, if you look at where Bach or Baroque composers in the 17th and 18th century, and then even through Haydn in the West, you find composers who can modulate, say, from C major. They can go to G, they can go to F, but they can also go to maybe to D minor, and some of it was called closely related keys. But they could not go to keys from C major to B major without a lot of difficulty, because you would create this very different kind of tuning relationship of the scales, which wouldn't be pleasant. So it wasn't until we get the capability of having equal temperament that composers in the really the middle of the 19th century, after Beethoven started pushing the possibility of modulation for farther away from C than many other people had done. But after Beethoven, really then we start to get much more of adoption of the equal tempered tuning system, and then from that you can find composers who can go to all 12 keys if they want. And so very quickly you have a lot more experimentation because the tuning system allowed them to do that. So those are the four main tuning systems. Once again, we started with Pythagorean tuning, and then we went to just intonation or Ptolemaic tuning, mean tone being another concept, and then equal tempered is where we've emerged today. Now I mentioned that there are many other kinds of systems of tuning systems around the world. These are perhaps the standard ones that are used in the West. But here again, as I mentioned, there's, if you look at classical Indian music, they pretty much have used just intonation tuning system throughout most of their history. And when you have, for example, in classical Indian music, you traditionally have a tambura, which is a drone instrument, which you'll find a player just constantly droning those strings. Usually the strings are tuned to the 3-2 perfect ratio, perfect fifth, which sets the scale. And then all the other pitches that the soloist is performing on will fit into usually some variations of a just intonation tuning system, but you have to identify the foundation of that, which is what the tambura is doing. So because they're adopting a just intonation tuning system, it doesn't allow for the possibility of modulation in that. So in Indian compositions, you really have never developed that classically traditional music, developed the idea of modulation because the tuning system was a just intonation tuning system. So here on this particular website, you can go through and look and listen to the different kind of thirds and seconds and so forth. And then there's a summary of other ones later here. I've also giving you a list of different other links to explore. There are a number of sites, Wikipedia sites, which have a lot of information. So if we look at equal temperament, for example, here you'll see, and I would encourage you to really explore these websites. This gives you a history of both the Chinese and the Western evolution of equal temperament, which is really quite fascinating. I won't take you through all of this in this class, but I will encourage you to take a look at these sites, and you can sort of see some of the comparisons between equal temperament and some of the other systems as far as how all the pitches work out. But it's a very interesting history as to understand how the relationship of these tuning systems has emerged as mathematicians, theorists have opened up possibilities. One of the perhaps most important mathematical developments that allowed for acousticians and theorists to tune to equal temperament was the development of the logarithm. I think John Napier, the Scottish mathematician, was credited for sort of discovering the logarithm. But through the logarithmic division, you can then calculate the 12th root of 2, which the 12th root of 2 is how you calculate the distance between whole steps in an equal tempered, or half steps in an equal tempered system. So once you can do that with a logarithmic understanding, it opens up for a much easier way to calculate that. So it was more difficult to figure out how do you calculate the distance between these before the logarithm was understood. understood. So that's why it's kind of extraordinary that some of the Chinese and Italians that were looking at this were doing this before they had the mathematics to really calculate the correct intervals. So that's equal temperament. So I encourage you to look through just intonation. There are a number of these sites that are worth exploring. Mean tone tuning, temperament here. Here's one on Ptolemy's, what's called the intense diatonic scale, which is the one that really was the foundation for just intonation. There's also something called well temperament. Well temperament was an evolution that really started, Bach is most famous for this, for doing his well-tempered clavier. Well-tempered was a type of equal temperament, even though it was not pure equal temperament yet. It was a type of tuning system that allowed for the composer to move around to various keys, but without too much dissonance between. They were not exact in the well-tempered, so there was some slight variance in the size of intervals, but they were close enough that you could move around and do compositions in each key with a slightly different flavor because of that. So when you hear J.S. Bach's well-tempered clavier performance today, and you have it tuned to the various exact kind of well-tempered tuning systems, it does have a subtle difference than tuning everything to equal temperament. So there's a lot of interesting kind of evolution of different kind of approaches to temperament. So I would encourage you to kind of look through all of these different websites and explore this further, because it's a very interesting area to examine. So what I'm going to do now is going to take you through some of the audio that I recorded earlier to listen to what's happening on the difference between equal temperament tuning and the just intonation tuning. So what I'll be doing, I'll be playing a few chord progressions in this on the Kurzweil K2500 RS sampler, which you can then hear, I think more dramatically, hear the difference between these two tuning systems. So let's listen to this, and I will try to show you on the staff what kind of chord progression I'm playing as we listen to this. Okay, I'm playing a Kurzweil K2500 RS sampler, and on a piano sound, a sample piano sound. And what I'm going to do, I'm going to play a C major scale in equal tempered tuning, which is the one that we hear today in most cases. And then we can, on this particular device, we can set it, the tuning change to a just intonation setting. So this is a just intonation scale tuned to a C overtone series. So we have low ratio partials on each pitch. So let's listen first of all to the equal tempered C major scale. And now here's the just intonation scale, also on C. It doesn't sound like there's too much difference there. When you just play the single notes by themselves, you don't really hear any difficulty there. But when we try to add harmony to this, we will hear some difficulties in that. Now, if I go back to the equal tempered scale, and let me just play a C major triad, which in the key of C major, it would be a 1 chord. And then I'll go from a 1 chord to a 4 chord, which is an F major chord, then to the 5 chord, the G major, and then back to the 1. So that's an equal tempered. Now let's do the same thing in just intonation tuning. Now you might be able to tell some difference if you listen very carefully, because the just intonation tuning will have the exact overtone series partials for the C and the G, and we'll have the more perfect fifths involved in that. There will be some difference in the major third, which we'll talk about as well. So let's hear that once again. And here's the just intonation perfect fifth, C to G. Here's the same C to G and equal tempered. Just, equal. Can't really tell too much difference there. Now listen to the C to the E, the major third, in equal tempered, and then followed by just intonation. And just, equal. Slight difference there. So now when we play the harmonies again in the equal tempered and just. You should be able to tell a different kind of resonance into the just intonation on this chord. Now the trick comes along when I try to change keys. If I do a different scale or a different key signature and change this, still tuned to a C overtone series, but if I try to play something in just intonation in, say, for example, B major, a half step lower, listen to what happens in just intonation on a B major. Obviously, there are things that sound more out of tune to us than that, because the C major overtone series, the tuning for that does not work into B major, because we get a whole different kind of relationship there. But now listen to B major if I go to the equal tempered. That's equal tempered. Listen again to just intonation on B major. So you can hear now equal tempered was a compromise system that allowed for the possibility of modulation, since we temper or change the tuning of the pure just intonation tuning system and make some adjustments in that are compromises to allow for each of the intervals to be tuned equidistance. And in doing that, it allows us for a capability of modulating and changing to any of the 12 keys in that scale. So this, in some ways, in other systems of music which only used a just intonation tuning system, such as India, you won't find modulation occurring, because in that tuning system it's very difficult to modulate. And historically, if you look back in Western music at the period of times when composers were able to modulate further and further away from the tonic key, it was accomplished only after there was more experimentation with the tuning systems. So now once again, just to hear that difference, if we go back to the equal tempered, here is the C major, F major, and here's a D minor, E minor, D minor, and major 1, C major. And do the same thing in just intonation. Even in the D minor chord, you can hear some different tuning that doesn't quite match up. So that's why the composers who are using more of a just intonation or even a mean tone tuning, where we do get some equal seconds involved in that, there were still some difficulties that composers were facing trying to move away from C major, because the further away you get, you do run into some tuning problems with that. So anyway, I hope that helps understand a little bit the sound that we're listening to on the difference between equal temperament and just intonation tuning. So as we start to think about temperament, we will start to discover a lot of composers in the 20th and the 21st century started to explore returning back to some of the older forms of tuning systems in temperament, but also trying to utilize the advantages of digital sound design in the fact that with a computer we can specify exactly the kind of tuning systems we want. And there was a lot more experimentation that started to occur, so we have composers who start to come out with their own very sophisticated tuning systems. Wendy Carlos is one of those, Lamont Young, Terry Riley, a number of composers who have worked with electronic devices this year, or even retuning acoustic instruments, have tried to explore larger scales, 31 note scales, 40, 51 note scales. So there are a lot of composers, through the capability of digital sound design options, are now starting to explore, are there new expressive possibilities that we can think about a new kind of scale arrangements with this particular tool, which allows us to become much more exact and really understand what's happening between those two. So tuning and temperament is something that is maybe not something that everybody wants to get involved with, but it is another aspect of digital sound design that I wanted to just throw out there to you to sort of think about. And understand when you're looking at different cultures, many times when you're looking at traditional music, you're moving into a whole different concept about how scales are put together, and what that means for harmony, for the vertical structures, is very different. And so that's why, as a composer or as a sound designer, sometimes if you're trying to evoke the aspects of a certain kind of music of a certain culture, changing the tuning system will help you get to the right sound and the right feeling for that culture. So hopefully this is something that you can explore more on your own, but it to me is one of the more interesting parts of being a sound designer.
The preceding program is copyrighted by Emory University.